All right, this is kind of part two of our adding and subtracting mixed numbers. And this is the one's going to focus specifically on subtracting and where something kind of weird happens. So that's where our essential question comes in. What happens when I get a positive number for one part? So maybe the whole number part of my problem, I get a positive number, but I get a negative number for the other part of my answer. So maybe the whole number in my mixed number is positive, but the fraction's negative. I can't really have that, so I got to find a different solution on how to tackle these problems. So we have two different methods for when this happens. So I'm going to kind of walk us through the first problem, let you kind of see what happens, and then kind of how to attack it. So first thing we do is we don't worry about anything. We just worry about dealing with our fractions. We got to find common denominators. So for 4s and 3s, the best option is a 12. Remember to change your numerators to match. So I get 4 and 3/12 minus 2 and, here multiplied times 4, and 8/12. So I can do 4 minus 2, but 3 minus 8 is going to dip into my negatives. So here's where I've got to attack it in a slightly different way. Our first method is go ahead and just change your new fractions into improper fractions. So we do 4 times 12 is 48, plus 3 is 51/12. Then we do 2 times 12 is 24, plus 8 is 32/12. And then we just subtract. 51 minus 32 is going to give me 19/12. But that's an improper fraction. 12 goes into 19 one time with 7 left over. Sorry, I don't know why I'm writing at an angle here. So change in the improper fractions. Go ahead and subtract them. Then change it back into a mixed number when you're done. So let's see that in action on another one. And this is one that kind of trips people up. But 7 is really 7 over 1. Okay? So if you're thinking, hey, this method might be my kind of method, go ahead, change this one into a mixed number right off the bat. So 2 times 9 is 18, plus 4 is 22/9. And this is 7 over 1. Again, first thing you have to do is you got to have common denominators. So good common denominator is going to be to use 9ths. To get from 1 to 9, I multiply times 9. So do the same thing up top. And I get 63/9. In this case, 22/9. 63 minus 22 is 41/9, which is really just a big improper fraction. So 9 goes into 41 4 times. 4 times 9 is 36. So if I took away 4 groups of 9, that's 36. Away from 41 leaves me with 5 left over. 4 and 5/9. So that's one strategy. If you get to where you can't do the subtraction, and like in this case, we didn't have a fraction to be able to subtract away, or here the subtraction was too big to subtract away, even though I could subtract the whole numbers, change them to improper fractions and give that a try. So here's method number 2. And you saw some of this in 6th grade. But what we're going to do is we're actually going to borrow. So think of a problem like 31 minus 19. We can't do 1 minus 9, so we went next door. This one goes down by 1, and then we added in 10, because we're dealing in base 10. This was the tens column, so I added one group of 10, and that allowed me to go ahead and do my subtraction. We're going to do something similar here. So in this case, sometimes it's easier to see it in a vertical setting. I can do 5 minus 3, but I can't do nothing minus 2/7. So what I do is I borrow. I take one of my whole numbers, so I'm going to leave 4 of them. I took 1, and I'm going to chop it up into pieces. I'm going to break it up into a fraction so I can do my subtracting. The key is break it up so it matches your other fraction. So I'm going to break it up into 7/7. It was one whole group, which is the same thing as 7 out of 7 pieces, but now I have enough fractions to do my subtracting. 4 minus 3 is 1, 7 minus 2 is 5, so I get 1 and 5/7. So I broke my whole number up into a fraction in order to allow me to do my subtracting. Same thing on our next one. And again, you're not going to know that you need to necessarily borrow or do any of this until you get into the problem. So when you look at this problem, the first thing you're going to go is, oh, I need a common denominator. Well, 14 is a good common denominator. To get from 7, I would multiply times 2. So do the same thing up top. And that gives me 4. So 6 and 4 14ths minus 2 and 9 14ths. It was already a 14, so I didn't need to change anything. But I can't do my subtracting. I can do 6 minus 2, but I can't do 4 minus 9. So this is where I have to do a little borrowing. So I'm going to rewrite mine vertically instead, just because I'm used to doing my subtracting in kind of that vertical format. Again, I can do 6 minus 2, but I can't do 4 minus 9. So I need to borrow, just like I did over here. I'm going to borrow from the 6, making it into a 5. So I basically took 1 of something. That 1 I'm going to chop up into pieces, and since I'm dealing in 14ths, I'm going to go ahead and make it into 14ths. 1 whole piece is equal to 14 14ths. So I borrowed 14, but I already had 4. So I don't get rid of them, I add them together. So I get 18 14ths minus 9 14ths. So all I did was just break up one of my whole numbers into a bunch of pieces, in this case 14 14ths. So I had more fractions to be able to do my subtracting. 18 minus 9 is 9 14ths, and then 5 minus 2 is 3. 3 and 9 14ths. So these two are for you. I want you to go ahead and tackle them. Use whichever of the two methods you feel most comfortable with, and then hit play and see how you did. All right, so hopefully you've given these a try, and now we can kind of see how we do them together. So again, you're not always going to know this is going to be necessary for us, so sometimes you just have to tackle the problem and see what shows up. First thing is a common denominator. For 6 is an 8, 24 is a good common denominator. Oh, being a little slow. To get from 6 to 24, I multiplied times 4, so I do the same thing up top, and get 4 and 4 24ths. Here, I would multiply times 3, and I'd get 15, or 1 and 15 24ths. And then here's where I notice that I have to do something. I can do 4 minus 1, but I can't do 4 minus 15. So I got to get creative. In this case, let's do our improper fractions. Right? Going to be some big numbers. That's okay. 4 times 24. That's going to be 80, 96. Plus 4 is going to be 100 24ths. Here, 1 times 24 is 24. Plus 1 is, that's going to give me 39 24ths. Sorry, I was being a little slow here for us. And then we subtract. 100 minus 39 is going to give me 61 24ths. And then I'm going to make it into a mixed number. 24 goes into 61 2 times, which is 48. 48 away from 61, so 61 minus 48 is going to give me 13 24ths. So I found my common denominators. I realized I couldn't do my subtracting, so I made them improper fractions. Then I turned that final answer back into a mixed number. So for the other one, I'm going to use my other method. I'm going to do 9 minus 4 and 3 11ths. I can do 9 minus 4, but I can't do nothing minus 3 11ths. So I'm going to borrow. My 9 becomes an 8. And I'm going to break that one piece that I have up into 11 11ths. It's still equal to 1 because I borrowed 1 whole, but now I made it into a fraction I can use. 11 11ths minus 3 11ths is 8 11ths. 8 minus 4 is 4. 4 and 8 11ths. No matter which method you use, no matter which one you're comfortable with, you'll get the exact same answer, but just make sure you're comfortable with how to tackle it and how to recognize when you need to use it.